This is number 70 in chapter 2. Number 70 has two parts. Part A says that your total displacement is 20. So you're starting out with an initial velocity of -8, and then you turn around at some point, and then your final velocity is 16. So here we're going -8 meters per second, and then finally we're going 16 meters per second. And the first part of the equation gives you a displacement. They tell you, and again, a displacement is a delta x is 20. Well, that is the x in the v squared equation. So v squared equals v naught squared plus 2a x, where that x really is a delta x. Final velocity of 16, initial velocity, in this case -8, but it's going to be squared anyways, plus sum 2 times a times x of 20. And that one works out pretty quick to find the acceleration of 4.8 meters per second squared. Part B talks about distance, and this is where we have to say, well, when we're going here, we're going to go a certain distance, we'll call that d1, and then we turn around and we go this way for some other distance, d2. And we know that total distance, in this case they give us, is 22. Here, displacement, we don't really care about moving left or right, it's all about a delta x. Here we care about how far we move left and how far we move to the right. Okay, so what we're going to do is we're going to do a v squared equation for both pieces. So if you write down the v squared equation again, if you think about the first phase of motion, we're going -8 meters per second, and then we stop, and we have a velocity of 0. So for the first phase, the final velocity of phase 1 is 0. The initial velocity is -8. And we're slowing down at some rate for some distance d1. So if we solve this out, we get 0 equals 64 minus 2a d1, which is saying that 64 equals 2a d1, and then if we divide, we can say then that 32 over a is equal to d1, and let's stop there. We have a in terms of d1. We can do the same thing for the other one. So the final velocity squared equals v naught plus 2ax. The final velocity in phase 2 is 16. Phase 2 starts with a velocity of 0 plus 2a and then some distance 2. So this is 256 equals 2a d2, which leads us to 128 over a equals d2. And then we can finish, because I'm going to make a substitution. This is d1 and this is d2, and I can put it in the original equation. So I can say 32 over a plus 128 over a has to equal 22. And then you can use some algebra to figure out that the acceleration must have been 7.27 meters per second squared.